Good afternoon, my dear student. Today we will discuss a new topic, that is source conversion. I hope everyone has good concept about this approach, source conversion. In this lecture, we will try to understand the fundamental concept behind this topic. How do we will convert a given source, maybe voltage source or current source, from one to another? Let me tell you the basic approach or steps which are involved in this conversion process. You see, I have taken an example of voltage source and I will tell you the steps involved for conversion of a voltage source into a current source. See, a voltage source is given here having voltage V and a resistance R is connected with this voltage source in series. Our objective is to design a current source from the given voltage source. So you know that an equivalent current source for this given voltage source is nothing but a current source which will provide a current I that will be equal to V by capital R, and the resistance R should be connected in parallel with the current source. So how do you will compute it? The first step, you just short the terminal, open terminal. In this case, A, B are open terminals. So you just place a short across these 2 points A and B, and later on you calculate the current, how much current flow through this short-circuited path. So you know the supply voltage is V and series resistance R, therefore the current which will flow through this short path AB will be equal to V by R. According to Ohm's law, we can write it according to Ohm's law that the current which is flowing through the short across AB terminal is equal to V by R, V divided by R. So therefore the current I equal to V by R. So you, after getting the current, you can design its equivalent current source of the given voltage source by connecting the same resistance of this voltage source in parallel with the current source. This is the approach to convert a voltage source into a current source. First step is to apply a short across the open terminal, I mean A and B. After that, you calculate the current according to Ohm's law, which will flow through this short path, and then you consider a current source having a current of V by R and place a resistance in parallel with the current source. Then you will get the equivalent current source of the given voltage source. Similarly, you can convert a current source into a voltage source. So first you need to calculate the voltage across the resistance R. If we consider the current source, equivalent current source, who is one we have got from the voltage source if we want to convert this current source into the original voltage source. What you will do, your first step is to calculate the voltage across the open circuit AB, across the open terminal A and B, which is nothing but the voltage drop across the resistance R. So you know the voltage drop across resistance R is equal to the product of current I and the resistance value R. So you, after getting the voltage V equal to IR, you can design the voltage source by connecting this resistance R in series with the voltage source. So I hope everyone understand the concept behind the source conversion approach. If a voltage source is provided to you and asks you convert this voltage source into a current source, you can convert it by placing a short across the A B terminals or open terminal. Then you calculate current through the short path and you design the current source which will provide the same current that is flowing through the short path and connect a same resistance of R value in parallel with the current source. Similarly, you can convert the current source into voltage source by calculating the voltage across the open terminal AB, which is nothing but the voltage drop across the resistance R. And everyone knows that resistance is always placed in series with a voltage source, and resistance is always placed in parallel with a current source, because we know that an ideal voltage source has internal resistance is equal to 0, and for an ideal current source the internal resistance is equal to infinite. So therefore, for practical case, we always actually focus on that things that input resistance of the voltage source must be very less, not, we will not actually make it equal to 0, but we will try to make it very less or very close to 0, maybe 0.001, 0.0052, like that range of ohm. And on the other hand, for a current source, we know that the internal resistance should be infinite, but for practical case we know that it is not possible to make the internal resistance for a current source is equal to infinite. So that's why we will try to make the internal resistance of a current source very high, okay, at least mega ohm or more than kilo ohm order. So I hope everyone understood the concept, the steps involved to convert a current source into a voltage source or a voltage source into a current source. Now I will give you a simple problem to convert current source into a voltage source. I will just give you, let me give few seconds. Okay. In next slide you will see a current source, and the question for you to convert this current source into a voltage source. Find the equivalent voltage source for the current source shown below. So everyone use the concept which one we have just discussed to convert this current source into an equivalent voltage source. So first step is to calculate the voltage drop across the open terminal, I mean the terminal A and B, which is nothing but the voltage drop across the resistance 2 ohm. So everyone first calculate the voltage drop across the resistance 2 ohms. Okay. First, everyone calculate to convert this current source into a voltage source. Step 1, we will first calculate the voltage drop across the resistance 2 ohm or across the terminal AB. So find the voltage drop across terminals A and B, which is nothing but the voltage drop across the resistance 2 ohm. So therefore, the voltage drop VAB is equal to the voltage drop across the resistance 2 ohms. That is nothing but equal to 5 ampere, 5 into 2 equal to 10 volt. 10 volt. Okay, so the equivalent voltage source will be a voltage source which provides a voltage 10 volt and having a resistance 2 ohm in series with it. The equivalent voltage source will be a voltage source. The equivalent voltage source is a voltage source is a voltage source which provides voltage of 10 volt and a resistance of 2 ohms is connected in series with it. Okay, so therefore the equivalent voltage source is nothing but the voltage source which provides 10 volt voltage all time and a resistance of 2 ohms is connected in series with it. So this is very simple technique that we can use to convert a given source to its another from voltage source into current source or current source into voltage source. Okay, now we will discuss a topic related to the source conversion approach, but here we will consider two types of forms of network. One is star and another one is delta. Okay, or pi and T network. Okay, so I hope you have little bit concept about this network, delta network and also star network. And these network are also known as, delta network is also known as pi network and star network is also known as T network. Now we will try to understand how do we can convert delta network to star network or star network to delta network. Okay, the first step is to calculate the resistance across the three terminals. You see, each network having three terminals 1, 2 and 3. These terminals are indicated or denoted by number 1, 2 and 3. If you want to convert from one from to another from, you know that they are correspond the resistance across each terminals across two terminals must be same for two network. If one network can be converted to another network, that means their terminal resistance must be same. If their terminal resistance are not same, then we can't do it. We can't do it. That means we cannot transform one from to another from. Okay, the condition is that their terminal resistance must be same. Then we can convert one to another. So for this case, if we consider the delta network, suppose we want to convert delta network to star network. So we will calculate their terminal resistance. Okay. So first you tell me what will be the terminal resistance for 1 and 3. For what will be the terminal resistance across the terminals 1 and 3 for delta network? So it is given as R31. R31. First you calculate the resistance between terminals 1 and 2, then you calculate resistance 2 and 3, and finally we calculate resistance between terminals 3 and 1 for two networks. Okay, you see the terminal resistance for terminal 1 and 2 is 1 and 2. If we consider 1 and 2, you see there are two parallel connection between 1 and 2 parallel connection of resistance. For one path is R12 and another path the combination of resistance R31 and R23. R31 and R23. So now everyone calculate the resistance between terminals 1 and 2 for delta network. For delta network, everyone calculate the resistance between terminals 1 and 2. And then you calculate the resistance between terminals 1 and 2 for star network and make them equal. Let me write this thing for your better understanding. So the resistance between terminals 1 and 2 for delta network is how much? You tell me. You will see parallel combination of R12 and the series combination of R31, R23. So that means you can write the equivalent resistance for these two terminals will be R12 parallel combination the series resistance R31 plus R23. you just see the equivalent resistance between terminals 1 and 2 for delta network is nothing but the parallel combination of two resistance. One is R12 and another is the resultant resistance series resistance of R31 and R23. So therefore we can write, for parallel combination the resistance is nothing but the ratio of product of the resistance divided by their sum. So we can write R12 into R23 plus R12 divided by their sum. R12 plus R23 plus R31. Okay. 23 plus R31. You just see, everyone, see, this is nothing but very simple approach, basic or fundamental concept. The parallel combination, if few resistance are connected in parallel combination, then their equivalent resistance is nothing but the ratio of the product of the resistances divided by the sum of those resistances. So therefore we can write this thing. Now everyone tell me, what will be the resistance for the terminals 1 and 2 for the star network? The resistance between terminals 1 and 2 for star network. Everyone, please keep in mind that delta network is also known as pi network and star network is also known as T network. In any competitive exam or your degree course exam, this network name can be changed. Okay, in exam maybe it comes like that, you convert the pi network into a T network or T network into a pi network. Sometimes it is also called Y network. Okay, so the resistance between terminal 1 and 2 for star network or T network or Y network is equal to, tell me, R1 plus R2. You see, there are two resistance connected in series across these two terminals 1 and 2. So therefore we can write R1 plus R2. And I told you that to convert one network into another network, for example delta network into star network, their terminal resistance must be same. The condition is that their terminal resistance must be same. So therefore we can write R1 plus R2 equal to the terminal resistance for delta network, R12 into R23 plus, I made a mistake here, you just change it, 31 R31, okay, divided by their sum, R12 plus R23 plus R31. Okay, so R1 plus R2 equal to R12 into R23 plus R31 divided by R12 plus R23 plus R31. Similarly, you can calculate the terminal resistance for terminal 2 and 3 for delta network. Sweetie Kumari, R1, R12, R31 divided by R23. Deepjyoti Roy, I will upload everything after completing this course. I will provide you the PDF copy PDF documents, I mean, after completing this first topic. And also I will give you some problems associated with this topic, which whatsoever we have completed, okay, so far and today. Okay, I will give you, don't worry everyone, I will provide everything whatsoever I have completed, and I will teach you, okay, through this course. Okay, so everyone, now calculate the terminal resistance for 2 and 3 delta network and also for star network, and make them equal. So therefore you can write, for next case we can write if we consider terminal 2 and 3. So terminal 2 and 3, you see, for star network there is two resistance are connected in series between 2 and 3. These resistance are R2 and R3. Therefore we can write R2 plus R3 equal to how much? The 2 and 3, you see, there similarly you can write parallel combination of resistance R2 3, and also the sum of resistance R1 2 and R3 1. So therefore you can write similarly R2 plus R3 equal to R2 3 into sum of R31 plus R12, R31 plus R12 divided by their sum, you can write. So R12 plus R23 plus R31. Okay, so similarly you can write R3 plus R1. Everyone write it yourself and tell me the expression for terminals 3 and 1. For terminal 3 and 1, everyone write the resistance between terminal of star network, and this is for terminals 2 and 3. Okay, and final one is you write yourself terminals for terminals 3 and 1. Okay, so everyone can write for 3 and 1 R3 plus R1 equal to R31 into R12 plus R23 divided by their sum, R12 plus R23 plus R31. Okay, R31 Nivedita Bhakal, R31 R12 R23 R12 R31 R12 R2. Yes, Nivedita and Pallavi both are correct. Okay, so now your object, you got the expression, means transformation expression between one to another, delta to star. Now your objective is to express R1, R2, R3 in terms of R12, R23 and R31, because in exam or practical case delta network is provided. Thank you sweetie, your answer is correct. Delta network is provided. R3 equal to R12 R23. Okay, delta network is provided, and question is, your objective is to design star network. So therefore, in this case, you derive the expression for R1, R2, R3 in terms of R12, R23 and R31, and you already got their transformation equation. Now you simplify this equation and tell me the expression of R1, R2, R3 in terms of R12, R23, R31. That means you express the resistances of star network in terms of resistances of delta network. Then you can design star network from delta network. Okay, so we have three equations. Now we will simplify these three equations and express R1, R2, R3 in terms of the delta network resistance. Okay, so let me tell you the final expression of R1, R2, R3 in terms of R12, R12, R21 and R31. So if we subtract equation 1 from 2 and adding to the result 3, okay, suppose you write this is equation 1 and this is equation 2 and third one is equation 3. Now everyone, equation 1, equation 2 and equation 3, now everyone do one thing, you just subtract equation 2 from equation 1 and after that you add the result to equation 3. Everyone first subtract equation 2 from equation 1 and then the result you add with equation 3. Let me write it. Everyone, to simplify, to solve this equation, subtract equation 2 from equation 1 and add the result to equation 3. Okay, equation 3. Then we will obtain, after that we will get R1 equal to, the final expression of R1 is equal to R12 into R31 divided by their sum, R12 plus R23 plus R31. Okay, then you will get R2 equal to R23 into R12 divided by the sum, R12 plus R23 plus R31, and finally we will get R3 equal to product of R31 into R23 divided by sum of the resistances R12 plus R23 plus R31. Okay, so everyone see the final expression of resistance associated with star network in terms of resistances associated with delta network. R1 equal to R12 into R31 divided by R12 plus R23 plus R31, the sum of all resistance in delta network. R2 equal to R23 into R12 divided by sum of the resistance, all resistances in the delta network, and R3 equal to R31 into R23 divided by sum of the all resistance in delta network. So you see that you can realize that in exam it is very difficult for a student to derive R1, R2, R3 in terms of delta network resistance. It is very difficult. So that's why there is an alternative approach or an alternative way, you can say, to remember these things. You can remember this thing as the resistance of each arm of the star is given by the product of the resistance of the two delta sides that meet at its end divided by the sum of the three delta resistance. So let me tell you to remember this thing, because in exam it is difficult for a student to derive whole things. It is better to remember it. First you derive yourself and later on you remember this thing. Resistance of each arm of the star network is given by the product of the resistances of the delta network, delta side you write, that meet at its end divided by the sum of the three delta resistance. Okay, so everyone see that this is very difficult for Amit Mishra. Sir, what is Amit, final result R1 equal to R1 equal to R12 R31 divided by, yes Amit, your answer is correct. Amit, your answer is correct. R1 equal to R31 into R12 divided by the sum of three delta resistance. Thank you Amit, your answer is correct. So this is an alternative way every student can remember this thing, because this is very difficult to derive during exam. So it is better to remember it. You can remember this thing like that. The resistance of each arm of the star network is given by the product of the resistances of the delta side that meet at its end divided by sum of the three delta resistance. If we consider R1, R1, so you see that terminal 1 for delta network, two resistance are connected, that is R31 and R12. So therefore the product actually the will be between R12 and R31. You see, if we want to calculate the resistance R1 for star network, and you see at terminal 1 two resistance are joined, R12 and R31, therefore product is nothing but the multiplication of these two terms R12 and R31 and divided by the all three resistance. Similarly, if we consider terminal 3, so R3 resistance for terminal 3 of delta network, you see that two resistances are joined together at terminal 3 of delta network, R31 and R23. So therefore product terms is nothing but multiplication of these two terms R31 and R23. So you see for R3 resistance of star network is ratio of the product of resistance R31 and R23 divided by sum of all three resistance. And similarly, if we consider terminal 2 for delta network, you see that there are two resistance are connected, that is R12 and R23. The product terms will involve R12 and R23 resistances. So if anyone have any doubt, you can ask me regarding the conversion of a delta network into a star network. Okay, in the similar way we can convert a star network into a delta network, delta network. So that in that case you will express the resistance of delta network R12, R23 and R31, three resistances, in terms of star network resistance R1, R2 and R3. Okay, so everyone please listen to me or try to understand. If I give you a problem like that, you convert a star network, convert a star or T or Y network into a delta or pi network. Okay, in this case your objective is to express the resistance R12, R23 and R31, okay, in terms of the resistance R1, R2 and R3. Okay, the resistance associated with star network. Everyone please see the next problem. In it's Y. Yes, Amit, Y. What? Let me check. Y network. Okay, thank you, Amit. Y network. So everyone, you already have realized that a delta network can be converted into star network by taking the product of the resistance meets at that terminals divided by the total resistances. Now if I ask you, you convert a star network or T network or Y network into a delta or pi network. So similarly, you will write the expression, the previous three equation you will use. The previous three equation 1, 2, 3 you will use to derive the expression of R12, R23 and R31 in terms of R1, R2, R3. So that in that case, what you will do? What you will do? You multiply equation 1, 2, 1, 2, 2, 3, 3, 1 and adding them together, then simplify them. So you get the final expression. So this case, what you will do? You multiply equation 1, 2, 3. Previous three equation we will use to derive the expression of R1, 2, R2, 3, R31 in terms of R1, R2 and R3. Okay, so multiply equation 1 and equation 1 and equation 2. Equation 2 multiply equation 1 and 2, equation 2 and 3, equation 2 and equation 3 and equation multiply equation 1 and 2, multiply equation 2 and 3 and multiply equation 1 and 3. Multiply equation 1 and equation 3. After that you solve it. After that you simplify it and adding them together and then simplify. After that add the results. Add the obtained result in previous step. Obtained result of obtain the product, actually add the obtained result mean product. Okay, multiplication output. So and then you simplify. So ultimately you will get the expression of R12, R23 and R31. The expression of R12 is R1 into R2 plus R2 plus R3 plus R3 plus R1 divided by R3. Let me write it, it's better. Then you simplify. Okay. Everyone, please simplify the expression yourself, and you will get the expression of R1 to R23, R31 in terms of R1, R2, R3. Let me tell you one problem for better understanding the concept, which one we have just discussed. Okay, so you see a problem here. Okay, a problem. You just see a problem. Find the input resistance of the circuit between the points A and B of figure A. one problem is given here to for better understanding the concept to convert delta network into star network or star into delta. So this is actually, you see a problem which one is given in figure 1. Objective, our objective R12 equal to R1 up into R1 plus R2. No. Your answer is R1 plus R1 plus R2 in plus R1 R2 divided. Yes, sweetie, your answer is correct. R12 equal to R1 plus R2 plus R1 R2 divided by R3. You can remember this thing as that the delta resistance between any two terminal is given by the sum of star resistances between those terminal plus the product of these two star resistance divided by the third star resistance. I will provide the soft copy PDF document of this topic, don't worry. So now you try to understand the solution of this problem. I have given a circuit. You see in figure A, the question is that you calculate the resistance between terminal A and B, I mean input resistance. So how do you calculate the input resistance? So I have given the graphical solution of this problem. You see, after figure A, I have given another figure. In this figure, you see a star network is associated with this figure. So the pi network in the original figure A, is converted into star network, into a star network in the second figure, and the bottom of the second figure, you see the parallel resistance between terminal S and B. Okay, the equivalent resistance of the parallel combination of few resistance between S and B is given 35 by 9. So therefore you can calculate the resistance between AB is nothing but the sum of resistance 4 ohms, 16 by 9 ohms and 35 by 9 ohms. Okay, so therefore this is the answer. The resistance between terminals A and B or AB is equal to the sum of resistance 4 ohm, because three resistors are connected in series, 4 ohm, 16 by 9 ohms and 35 by 9 ohms. So this is an application of delta to star network network in order to calculate the input resistance of a circuit. Okay, so in this lecture we have understand the source conversion from voltage source to current source to voltage source, internal resistance of an ideal voltage source, of an ideal current source, as well as practical sources. And then we have studied or discussed about the network conversion, especially delta network and star network or phi network and T network or Y network conversion. So, and the final problem is nothing but the application of the delta to star network conversion in order to solve the problem. I will give you many problems regarding this topic, delta to star conversion, star to delta conversion. Okay, as a PDF form or as an assignment I will provide you. So but you see, everyone try to understand that the pi network is converted into a Y network. In the original figure, pi network consists of resistance 4 ohms, 6 ohms and 8 ohms. That means the portion of the original network figure A, in figure A, that is lies between terminal CDE. The portion of CDE, you can say the section CDE is a pi network. CDE is a pi network. This pi network is converted into a Y network or T network. CDE portion in the second figure. And finally, you simplify that second figure because you see there are two parallel combination of resistance between between AS and B terminal, and you calculate the equivalent resistance, and finally you will get a circuit which has three resistances in a series connection. So ultimate, the sum of these three resistances will be the value of the resistance between A and B. Okay. Any doubt? Okay, thank you. Now I will give you a little bit complex problem related to star to delta or delta to phi network conversion. This one is very simple. Now I will give you a little bit complex problem. That this problem, you see, Harsraj, not a complex problem. Actually, this is you use star delta conversion concept or delta to star conversion concept to solve this problem. Okay, to solve this problem, you see, this network is a combination of two types of network, delta as well as star. ABC, you see, ABC is a delta network, mean outer network is a delta network, but if you consider inner network, A, D, DC, DB is a T network or Y network. Now the question is, you calculate the resistance between AB terminal, BC terminal and CA terminals. Okay, so how do you will solve this problem? Inner is a star network. Orkodip, yes, inner is a star network and outer is a delta network. And you see the question, what will be the resistance between AB terminal, between BC terminals and between CA terminal. So now you tell me, anyone, how do you solve this problem? Harsraj, delta, yes. How do you solve this problem? You see, this is a combination of two networks, star and delta, and your objective is to calculate their terminal resistances AB, BC, CA. So how do you solve this one? Anyone tell me what is the step? First step, we'll convert star to delta inner one. Amit, star to, yes, thank you Amit. Thank you very much. Your answer is correct. Absolutely correct. Everyone must convert the star network into delta network. Star network into delta network. Orkodip, yes, your answer is correct. After that, you will get, after converting the star network into a delta network, you will get parallel combination of two resistance between AB terminal, BC terminal and CA terminal. So after that you will calculate the then it will be in parallel. Yes Amit, then it will be in parallel, and then you can calculate the equivalent resistance of two parallel resistance. Two resistance in parallel connection. Thank you very much. Sweetie Kumar, we can convert inner one star to delta. Okay, good. So everyone, first convert star into delta, then you will get parallel combination of two resistances across AB, BC, CA terminals, and finally you calculate the equivalent resistance of parallel connection of two resistances. That will be the final answer. Thank you everyone. If anyone has any doubt, you can ask me, and I will provide you the documents topics with whatever we have covered. Okay, and I will also provide some problem associated with this topic. And another thing, I will take virtual lab session on Thursday, I mean tomorrow, for group B. Group B, I will take the virtual lab session for group B student. Tomorrow I will take the virtual lab session from group B student from 12:30 p.m. and Friday group A student. Okay, any doubt? Actually, Amit, PSpice software has a little bit problem. It is difficult to use at present. Okay, the virtual lab experiment is good. If you want to implement your experiment in PSpice software, you can install yourself in your machine and you can ask me if you face any problem. But it is difficult for all students to install PSpice software and its availability also, from where they will collect, and then how do they will handle this software. So that's why it is better at present time to use virtual lab and understand the practical application or practical implementation of the theory, okay, of circuit theory associated circuit theory. I know other batch using that, Amit, I know, but it is not actually, I mean, feasible for all students, because we have already taken 2 experiments. That's why it's good for all of you. It's good for all of you to use virtual lab to implement the theory part, to verify the theory part experimentally. If you want to use Amit PSpice, you can install yourself in your machine and you implement all experiment, and if you face any problem you can tell me, but it is not feasible for all students at present. Thank you everyone.